Hello guys, and today's topic is separating mixtures. Learning goal. I can describe what are mixtures. I will be able to list methods used to separate mixtures. Keywords. Mixture. It is a combination of two or more substances that are physically combined but not chemically bonded. Formulation: a carefully designed mixture with specific amounts of substances to achieve a desired function. Separation: the process of dividing mixtures into their individual components. Mixtures. Mixtures are combination of two or more pure substances. Pure substances can include elements or compounds that are not chemically combined. Example: rocks, seawater, air, muddy water. They're not chemically combined, but they are mixed together. Air is a mixture of several gases like nitrogen, carbon dioxide, oxygen, water, etc. This is air, okay? Any teeny tiny part of it, what it will have: nitrogen gas in it, carbon dioxide in it, oxygen in it, water molecules in it, and many more other gases as well. Question time for you. True or false? A mixture is the one which is chemically bonded together with its components. Pause the video, think, and then check whether you are correct or no. If you answered false, then you are correct, because the components of mixture are not chemically bonded together. Mixtures, you can see that soft drink is a mixture of 5 different substances, but it looks and behaves like a single substance. In this soda can, it has flavoring agents, it has carbon dioxide gas, water, sweetener, and flavoring agent. But when you drink it, it's just one liquid, right? So it behaves like a single substance but has many different substances in it. Previously, we did pure substances. Now, what is the difference between mixture and pure substances? A mixture is combination of two or more substances that are not chemically bonded together and can be separated by physical methods. For example, air, seawater, milk. You can separate salt from water, then you can separate oxygen from air or nitrogen from air. Now, pure substances, a material made up of only one type of element or compound with a fixed melting and boiling point. For example, oxygen, water, sodium chloride, gold, they all are pure substances, that is, nothing is mixed with them. Mixture change state of matter over a range of temperatures. Now, for pure substances, we know that melting point and boiling point, they both have single or fixed or specific numeric value. But for mixtures, there will be a range, just like impure substances, which we did. It has a range of temperature. For example, brass. Brass is a mixture. It is a mixture of copper and zinc. The melting point of brass varies between 900 degrees Celsius to 940 degrees Celsius depending upon the composition. But if you separate the mixtures, copper and zinc, copper will melt at 1085 degrees Celsius and pure zinc will melt at 419 degrees Celsius. Question time for you. Which of the statement or statements is true for mixtures. Mixtures do not have fixed melting or boiling points, while pure substances do. Second is mixtures contain two or more types of particles, while pure substances contain only one type of particle. And the third is mixtures keep the original properties of their components. Pause the video, think, and then check. If you answered all three, you are correct because mixtures don't have fixed melting or boiling points. Mixtures contain two or more particles, whereas pure substances contain only one type. And also, mixture keep the original properties of the components. Now comes formulations. Some mixtures are called formulations. But what are formulations? Formulations are a carefully designed mixture with specific amounts of substances to achieve a desired function. For example, medicines, fuels, food products like toothpaste. There are flavoring agents, binding agents, active ingredients, coloring agents, stabilizer in a formulated product. In here, you can see the examples like toothpaste. Every time the consistency of the toothpaste remains the same. If you try Colgate, you can see that every time you use the same toothpaste, the taste doesn't changes. So that is a formulated product. It has specific amount. Similarly, when you take a paracetamol, it tastes the same. Its properties are the same every time because it has a proper formulation. Which agent, which active ingredient, which binding agent, flavoring agent has to be added in what amount, it remains the same throughout. Question for you. Which of the following are examples of formulation? Paint, fertilizer, shampoo, sand water, lip balm, or seawater? Pause, sort out, and then check your answer. If you answered that formulation includes paint, fertilizer, shampoo, and lip balm, you are correct because all of these are having proper or specific proportion of the ingredients in it. They never change. Separating mixtures. Mixtures can be separated into their pure substances by techniques including decanting, magnetic separation, filtration, etc. The components' properties play a huge role to decide which technique will be the best to separate a mixture into its different parts. It is because mixture keep the original properties of their components, hence we are able to find how to separate them. For example, seawater, it is a mixture of salt and water. We know that salt is solid, it has a very high boiling point, whereas water has a boiling point of 100 degrees Celsius. So based on their boiling points, we can easily separate salt from water. Air, mixture of carbon dioxide, nitrogen, oxygen. Alloys, mixture of metals. Based on the properties of the mixture, components of the mixtures, we can easily identify how we have to separate our mixture. Separation techniques. Separation method, the property used to do this separation. Then few examples. First is filtration. Property used as physical state, separating sand from water. Sand is solid, water is liquid, so separating solid from a liquid. Magnetic separation based on magnetism, separating iron fillings from sand. Sieving, particle size, sifting flour to remove larger particles. Decanting, solubility and density. pouring of water from oil and water mixture. Fractional distillation, based on boiling point we can separate. For example, separating crude oil into fractions like gasoline, diesel, etc. Electrolysis. Property used is electrical conductivity. For example, splitting water into hydrogen and oxygen. Chromatography. It is based on optical properties like separating ink pigments in a marker. Crystallization. It is based on solubility. Purifying sugar from a sugar solution. Settling. It is based on density. For example, separating mud from water by allowing the mud to settle. Question time for you. Classify the following as properties used to separate mixtures: ions, chemical bond, electrons, physical state, solubility, magnetic property, boiling point, density, pressure. Pause the video, separate out, and then check whether you were right or wrong. If you classified properties as physical state, solubility, boiling point, magnetic property, and density, you are correct because based on these properties, you can easily separate mixtures. Check out YouTube Shorts or Instagram handle or TikTok for related practice questions.